This next video for 2.1 is called Functions Defined Piecewise. And again, I kind of feel like sometimes the material jumps around a little bit. You know, it's funny how this is chapter 2 and yet we're sort of going back to something that we did in chapter 1. But we're going to go back to this idea of functions being defined as expressions. So here we've got f at x being defined as three different expressions. So it's being defined as 4 minus x squared, and 2x minus 6. And the reason it's being defined by different expressions is because they're going to restrict the domain, which is why we've been talking a lot about, you know, domains and sort of how they fit in with things and how to find them. But these are arbitrary. These aren't for specific reasons, but they're going to restrict the domain so that even though we're graphing our graph in pieces, it's going to end up as a function. What I mean by that is that they're going to tell you that f of x is equal to 4 for any x value that's less than or equal to 0. So if you plug in any x value that's less than or equal to 0, so for this domain here, then the y value is always going to be 4. Right? So all the way along here, the y value is 4. Then between 0 and 2, you're going to define your function as 4 minus x squared. So for any x value that's between 0 and 2 inclusive, but not including 0, you're going to use this equation. So this is going to be that quadratic shape, right, that U. And so you'll notice that the graph changes. This piece is a straight line, then it goes to this U shape, and then from 2 on, you're defining it with a linear function. And so you end up with this graph. Now, in order to make this graph a function, there's a reason why if this is equal to 0, this won't be equal to 0. If this is equal to 2, this won't be equal to 2. So that if I do the vertical line test, you know, even at this point here, you'll notice that I pass through a point and then this one's a ghost. It doesn't exist. So the whole entire graph, even though it's defined by different pieces, ends up as a function. Now I like these, I quite enjoy them. I find students either like them or hate them, but I'm going to start with a warm-up. So I'm going to start with a warm-up by saying, hey, you know what? If I give you this piecewise function, okay, so it's a function defined by different pieces, and I say, hey, find the value of your function at -3. What I'm telling you is that -3 is going to fit into one of these domains. Which one? Well, this one's x is less than or equal to 0. Is -3 less than or equal to 0? Yeah. So for an x value of -3, you're going to plug into this expression. So f at -3 is equal to 4, and you're done. What about when x is 1? So when x is 1, which domain does it fit in? Well, 1 is between 0 and 2, so it fits into this one. So you're going to plug in, for the x, you're going to plug in 1 to this expression, right? Because the 1 fits into this domain. So you're going to define your function using this piece. Okay, so then you end up with 4 minus 1 is 3. All right, what if I want to plug in 2? Well, the only one that's equal to 2 is again 4 minus x squared. So we would plug in 2 for x, and we would get 4 minus 4, which is 0. So then if I wanted to plug in f of 4, I'm like, well, which domain? Is it less than or equal to 0? Nope. Is it between 0 and 2? Nope. Is it greater than 2? Yep. So I'm going to plug in x into 2x minus 6. So 2 times 4 minus 6. I feel like I said that weird, but you know what I meant. So 2 times 4 is 8. 8 minus 6 is 2. And what we did is just found some of the points on my graph. When x was -3, y was 4. When x was 1, y was 3. When x was 2, y was 0, and when x was 4, y was 2. So we found these little parts within the piece. So that's one thing we can do. The next thing we can do is actually graph the entire function piecewise. So how do we do that? Well, what I do is I make tables of values, and I do them a piece at a time. So the first one, f of x is just y. So I'm going to graph y is equal to x squared. Now, the equation is defined as x squared for x values that are less than 0. So I'm going to actually start at 0 and then pick values that are less than 0. So like -1, -2, maybe -3, however many I want. But I'm going to be careful. Because I'm not equal to 0, I'm going to make sure I circle this point because this is going to be one of those ghost points. It's going to be one of those points that's there, but it's a boundary. It doesn't actually exist. So let's plug into our equation. So when x is 0, y is 0. When x is negative 1, y is 1. When x is negative 2, y is 4. And when x is negative 3, y is 9. Okay, so I'm going to plot these points. I've got a point 0, 0. Now, I reminded myself that this is a ghost point, so instead of drawing a solid dot, I'm going to draw an open dot at 0, 0. Then my rest of my points are negative 1, 1, negative 2, 4, negative 3, 9, which doesn't fit, so I can't put it, but I know where I'm going to. I'm heading up. So I picked enough points that I could get an idea of what the graph would look like. And I know that I should put an arrow on the end because it's any value less than 0. So it's going to keep going even though it doesn't fit on my grid. Then I'm going to do the same thing for the next piece. So the next piece is y equals x plus 1 for any x value greater than or equal to 0. So this time I'm going to start at 0 again, but I'm not going to put a circle. It's not a ghost point. So I'm going to pick a point like 0, 1, 2, 3, however many I feel like I need to get a picture of what it looks like. So when I plug in x is 0, y is 0 plus 1, which is 1. When I plug in x is 1, 1 plus 1 is 2. When I plug in 2, 2 plus 1 is 3. I can see a pattern. I can stop doing this. 3 plus 1 is 4. So then I plot those points. So at 0, when x is 0, I have a y value of 1. This one's a closed circle because it's equal to. Then I have a point at 1, 2. Then I have a point at 2, 3. And then I have a point at 3, 4. Now again, this is just a representation of different points. And so I know that these actually go along, and I have a hard time drawing straight lines, so I'm going to draw more. Okay, but you guys have rulers, so you don't have to put as many. And there we go. So this is my function defined piecewise. This is how you get funky shaped graphs, okay? Is that like there's all these, I remember teaching at one point, I was like, make me a kitten head. So people would do like a little parabola and then maybe a straight line and then another part of the parabola. And then maybe you could do like another straight line followed by another straight line to make ears. Okay, that's looking nothing like a cat, but you know what I mean. So to get these funky shaped graphs, you just define little pieces and you're like, hey, restrict the domain. Only do this shape when x is this to this. Only do this shape when x is this to this, and so on. All right, next page. So this one has 3, right? But I'd love for you to give it a go. So pause the video and see if you can graph this piecewise, so piece by piece. My hint to you is make your table of values. So my first one is y equals 4 for any value less than or equal to 2. So 2, 1, 0, negative 1. Then we use y equals x plus 1 for any values between 2 and 4. 2, 3, and 4, the only ones I can give. Now, careful. As soon as you see that they're not equal to, those are going to be ghost points. So circle, circle. Okay, and then table of values for where x is greater than or equal to 4. Okay, pause the video if you haven't done so yet. I was told by a student, always count to 5 when I say pause the video so that they have time to find the pause video button. And then it just makes it less stressful. Okay, so here we go. Now for the first one. When I plug in any x value, y is just 4. It doesn't matter what x is, y is 4. So for every single one of these points, y is 4. So when x is 2, y is 4. When x is 1, y is 4. 0, 4. 1, negative 1, 4. Negative 2, 4, and so on. So this graph is a straight line going that way. And again, you guys are using rulers. Okay, now I want to do this section. What is my y value when x is 2? Well, y equals 2 plus 1 is 3. When x is 3, 3 plus 1 is 4. And when x is 4, 4 plus 1 is 5. So when x is 2, y is 1, 2, 3, open circle. When x is 3, y is 4, closed dot. When x is 4, y is 5, open circle, and then connect them. Okay, I've done that piece. And the last one is y equals negative x My domain is restricted to 4 and up, so I'm going to go 4, 5, 6, and I plug it in. When x is 4, y is negative 4. When x is 5, y is negative 5. And when x is 6, y is negative 6. And then I plot my points. Nothing to be careful of, no ghost points. So I've got when x is 4, y is negative 4. When x is 5, y is negative 5. When x is 6, y is negative 6, and so on. So the last part of this function looks like this. So this function had 3 pieces. It looks super bizarre, right? But you can see piece 1, piece 2, piece 3. And if I did the vertical line test, it would pass. All right, go do your quick check and good luck.